So survey found that odds in favor. How about I'll give you a quick crash course. This is probably not the best entry on your study sheet, but I would just say, in general, when I think of probability, let's say it's 2/3, and I want to turn that to odds, I go 2 to 3 minus 2. It's 2 to 1. Like, that's just a quick little reminder, right? When you want to turn probability to odds, you do it that way. If you go from odds, like 4 to 5, let's say, and you want to turn it into a probability, of course it would be more complicated than that because it has to be probability for or against, right? Odds in favor or against, I know that. But in general, I'll take one of these numbers, put them on top, and then I go 4 plus 5, that's 4 over 9, okay? This is just a quick review on going from probability to odds or vice versa, okay? So I would elaborate a bit more on this, but for now I'm just gonna say, hey, this is at least a reminder that make sure that your odds do not have any, no total in it, okay? So a survey found that the odds in favor of a male choosing football as their favorite sport was 72 to 18. In favor, so that would be football, not football. So any other sport other than football, right? Because of the wording. Next, this is what I want you to, this unit, please read carefully. Is it saying probability? Is it saying odds? Or is it just saying how many ways can someone answer? I'll tell you a little bit more about that later, but in this case it's clear it's probability. Football. So we're going to go football over 72 plus 18. That's 72 over 90. It reduces to 4 out of 5, but that's okay. State the probability of a male not choosing football as their favorite sports. Because you have them here, like you have that 18 there, that means not football, right? I'm just going to put that on top, and it's still out of 90 because I'm basing it off of the same odds. So that's that. It reduces to 1 out. How about this? Just to see it, easier to see, right? If this is 4 out of 5, wouldn't it make sense that 1 out of 5 would not like football, right? It's easier to see sometimes when the numbers are a bit smaller. 1 mark each so far. State the odds against males choosing football. All you have to do, because they're already, you have the odds in favor, you just have to flip it, and there you go. Okay, that's all you have to do. A survey found that 16 out of 21 teenage girls have bought makeup at MAC. Okay, state the odds in favor of a girl shopping at MAC. So basically, you would want MAC and then not MAC, like Sephora, or something like that. Anyways, then, so because this is 16 out of 21 are going there, then I would want 16 here, and I would want 21 minus 16 on the other side, like not, right? So this would be 16 to 5, and they add up to 21, right? So this is the answer to 4. The odds against shopping at MAC, that would be just flipping. So if you got this wrong, this 16 to 5, as long as you're flipping the numbers, you still get the mark for 5. That's a step mark. Follow through. Okay. State the probability of girls not shopping at MAC. Several ways of doing it. You have them not shopping right here. It's 5. So it's probably just easier to say 5 over 21 like that. How many outcomes are possible when flipping a coin and a 4-sided die? Notice just how many outcomes. It doesn't ask us for probability. It doesn't ask us for odds. It's just how many. This is going back to chapter 4. So it would just be 2 times 4, 8. Hi, you need me? So that's Thank goodness for autosave these days, because a lot of tests would have been gone now. State the probability of rolling a 3 in the previous question. A 3 would just be 1. If you need an outcome table, do it. But it's just 1 out of 4. Oh, sorry. Am I on the right question here? 8. It's 2 out of 8. So let's do a little outcome table, shall we? 1, 2, 3, 4. And you've got heads or tails. So you've got heads 1, heads 2, heads 3, heads 4. If you need to do this on the back side, that's fine. Tail 1, tails 2, tails 3, tails 4. So rolling a 3, how many options in this case? Because you got to do both of them at the same time every time. There's 2 out of 8 that meet the criteria, which is 1 over 4. It reduces to 1 over 4, so either one is fine. And it did say probability, so you got to have 2 numbers. And make sure the probability, the bottom number, is always the largest, okay? Always. How many ways can 4 different cars that is, be arranged? 4 factorial, or 4 pick 4, or if you want to do the fundamental counting principle, that's fine. That's 24, right? How many groups of 4 can be created out of 12? Groups, no order in particular, just making teams, groups, packages. So that would be 12, choose 4. Okay. And what would that be? 495. How many 6-letter words can be created using the word letter? So 1, 2, 3, 4, 5, 6. Of course, there's 6. That'd be 6 factorial divided by, there's 2 T's and there's 2 E's. And so that it ends up being 180 ways. So some is, I mean, this is really, this chapter mixes it all up. Some probability, some odds, and some chapter 4 stuff where you're just finding the number of ways. Next, state N of pizza, right? So you want to know how many are in here. The number of, right? So it'd be 4. This is a bit controversial. But when you don't have several numbers, you count it's 4 plus 3, that's 7, 9, and 5 is 14. Okay? So it's 14. They're talking 14 people that they surveyed, so it's 14. It's not 1, 2, 3, 4. Okay? You do the counting individually if you have several numbers in each region. Then you know each number represents one element. Okay? The union between pizza and hamburger. So when it's union, you want to include everything. Forget about tacos, right? That's what we want right now. So it would be 14 plus another 3, that's 17. State N of not T. Focus on tacos first. So this is 7, 10, 11. So you've got 11 tacos, right? So we're going to go universal. Do you remember that one? Universal minus tacos, yeah. So did you figure out the universal already? Let's see here. My universal is 30. I just added everything up, including the outliers. This is kind of weird here, right? You're thinking it's the intersection. No, it's just outliers. So 30, so I'll go 30 minus 11, and that would be 19. You could have also just covered everything in there and just added up everything that isn't inside tacos, then you're fine, including outliers, that is, though. This one is a little controversial. State the universal set. It doesn't say N, right? It doesn't have the N in front of it, so technically we would want to list all the things that are in there. You can't do that. You don't know, right, how many elements or whatever. So I meant to say this. That's what I meant to say. If I ask you to state the set using notation, there would have to be names in there. Okay, so 4 people, for example, that said they love pizza only, you'd have to have the names of those individuals, and then you would list them, right, with squiggly brackets like that. But in this case, it's just 30. This is just going to be an additional here. This will be a bonus. The odds of pizza. I know this is terribly worded, the odds of someone liking pizza, right? But if I asked you, what are the odds of pizza? Could you do that? And then 7, these are bonus. What's the probability of taco? Probably of someone liking tacos, right? Okay, odds of pizza. We know that 14 people like pizza and therefore 16 do not like pizza, because I know we have 30. So these two have to add up to the universal. You can reduce that, right? That'd be 7 to 8. 7 to 8 reduced. Plus 1 if you got this. Probability of taco, that would be 14 out of 30. You already know, no wait, tacos we've got 11. That's what I was trying to say. 14 is the new 11. So 2 bonus marks if you got that right.